This video is about introduction to hypothesis testing. So first of all, let's see what is a hypothesis in statistics. Okay, here's the definition. A hypothesis is a claim or statement about a property of a population. So the first sentence, the mean body temperature of humans is less than 98.6 degrees Fahrenheit. So this is a hypothesis. Usually we will be asked to write it in the symbolic form. So in symbolic form, since we're talking about the population mean here, we use mu. Mu is less than 98.6 degrees Fahrenheit. Okay, now the second. Here it says more than half of the consumers are not comfortable with drone deliveries. So what property of population we're talking about? That's right, we're talking about the population proportion. So we use P. The population proportion is more than half, so greater than 0.5. P is greater than 0.5 is this hypothesis in the symbolic form. The last hypothesis. The population of college students has IQ scores with a standard deviation equal to 15. So the last population property we're talking about is the population standard deviation. We use sigma. So sigma here is equal to 15. That is this hypothesis in symbolic form. Next, we'll talk about what is a hypothesis test. It is a procedure for testing a claim about a property of a population, basically a procedure of testing a hypothesis. So first we need to understand two kinds of hypothesis. One is called the null hypothesis and the other is called the alternative hypothesis. For a null hypothesis, we usually use H0, or you can call it H0 to represent. Well, this is the statement that the value of the population parameter is equal to the claimed value. So remember, for the null hypothesis, it's always with an equal sign. The second hypothesis is called the alternative hypothesis. You either use H1, some textbook use H1, some textbook use HA. So it is a statement with an inequality in it. So basically it's usually less than or greater than or not equal to in the hypothesis. So for example, for the null hypothesis, here are three different null hypotheses. You can tell here it says mu is equal to 98.6 degrees Fahrenheit. That's a null hypothesis because here it says the population mean is equal to a certain number. The second null hypothesis, P equals 0.5. P is the population proportion. Here we have the equal sign, is equal to a certain probability. The third null hypothesis is sigma. The population standard deviation is equal to 15. Okay, so these three are null hypotheses. The reason for that is they all have equal signs in their statement. Okay, now let's look at alternative hypothesis. Remember we said it is a statement with inequality signs, either less than or greater than or not equal to. So for each of the null hypotheses, you will have three possible alternative hypotheses. For example, for the first null hypothesis, mu equal to 98.6 degrees Fahrenheit, it is possible to have these three alternative hypotheses. Mu is greater than 98.6 degrees Fahrenheit, mu is less than, mu is not equal to. Right, similar for P equals 0.5, it is possible to have three different alternative hypotheses. Similar for here. For mu equals 15, you have 3 possible alternative hypotheses. However, when we're doing a hypothesis test, we will only have one pair of null hypothesis and alternative hypothesis. So since we have 3 possible alternative hypotheses, which one should we pick, right? So here is how. So for example, say we're given this statement. This is the claim. It says the mean body temperature of humans is less than 98.6 degrees Fahrenheit. So the first step is to express this claim in the symbolic form. So we did that earlier. It will be mu is less than 98.6 degrees Fahrenheit. Right. So now we want to write the statement that's exactly opposite as the claim we just write down in symbolic form. So the opposite of this statement, mu is less than 98.6 degrees Fahrenheit, will be mu is greater than or equal to 98.6 degrees Fahrenheit. Okay, so first you write down the claim in symbolic form, then you write the opposite statement in symbolic form, and then you look at these two. The one with no equal sign will be the alternative hypothesis. So since the second one has an equal sign here, greater than or equal to, we will use the first one as our alternative hypothesis. Remember, your alternative hypothesis can only have greater than, less than, or not equal to. So this one without the equal sign will be your alternative hypothesis. So H1 is mu is less than 98.6 degrees Fahrenheit. And the one with the equal sign will be the null hypothesis. Writing the null hypothesis and alternative hypothesis is usually the first step of a hypothesis test. So let's practice a problem. Okay, so here it says 1,009 consumers were asked if they are comfortable with having drones deliver their purchases, and 54% of them responded with no. So here's the claim. More than half of the consumers are not comfortable with drone deliveries. So first we want to write the null hypothesis and the alternative hypothesis. What do we look at? We just look at the claim. Okay, so first we want to write the claim in symbolic form. So given the claim, more than half of the consumers are not comfortable with drone deliveries. In symbolic form, it will be P, since it's talking about the population proportion, more than half. That will be greater than 0.5. This is the claim in symbolic form. So now to find the null hypothesis and alternative hypothesis, first we want to find the exact opposite statement of the claim, which is P is less than or equal to 0.5. Okay, so out of these two, the one without the equal sign will be the alternative hypothesis. So H1 is the one without the equal sign, which is P is greater than 0.5. And H0 or H0 is the one with the equal sign. You just change the statement into P is equal to 0.5. So here's the null hypothesis and alternative hypothesis.